Recording in progress.
Good morning.
Good morning.
How are you?
Morning.
I'm good. How are you?
Good.
Doing all right.
Yeah. We missed you last week.
I know. I'm sorry. It was.
Morning.
Yeah, I took work off. I didn't tutor Thursday night, and I didn't tutor Friday morning. It was just
had stuff going on.
lots of stuff. But I think I got it mostly taken care of, so that's good.
Jack's microphone is acting up today.
Mm-hmm.
Hey, good to see you. It's Thanksgiving week here.
Mm-hmm. Ready for some turkey.
We've got people on YouTube who are probably not from the United States who are probably not familiar with this holiday of. Well, I guess we celebrate arriving in the New World, more or less.
Yeah.
Surviving the first winter.
Yeah.
And
By
so,
gourding ourselves with as much food as we can fit in our stomach.
Yeah. Traditionally, we roast a turkey, and because that, I guess, was at the time a pretty plentiful bird. Although the turkeys you can get now in the store are much much fatter than they would have been back in the 1700s or 1500s maybe.
Yeah.
1400s. And what else do you have? What's traditionally on your meal?
Cranberries and green beans and stuffing and mashed potatoes with gravy and all the
carbs you can eat, right?
Yep. Big cornucopia of just stuff.
Pies.
Oh yeah, pumpkin pies.
And then the obligatory afternoon nap.
That's right. All that tryptophan, and then it's time to sleep.
Oh, someone said, I think the Mythbusters did one. Is it the tryptophan or is it just the carbs? And I think they determined it's just the carbs. It
could be, yeah. So I did a research paper on it a little while ago, and a couple years ago. And the it's any protein really. Any protein creates melatonin, which helps you fall asleep. So any kind of protein, it doesn't have to be turkey, but turkey creates a little more than other proteins. But yeah, steak or hamburger or anything really. But any kind of protein like that helps your brain create melatonin to fall asleep.
And at this point in my life, I've discovered that if I just eat Mexican food, I'll fall asleep. I mean, because it's the tortillas and the meat.
Yep.
Pow! An hour later, I'm out. So I really have to watch how much I eat. Because you go there and you know they usually serve you a basket of chips first, right? And you're gorging on those. And then,
oh yeah. It's good food. Yeah. I love Mexican food.
So that means on Thursday we won't have a stream because we'll all be either sitting around waiting for the turkey to be done or busy in the kitchen actually cooking the turkey.
Yep.
That's what I do.
How do you cook it?
You
just roast it?
Yeah. Last year we tried smoking it.
Ooh.
Well, the problem we had last year was we don't have a smoker. So I was just using smoking chips inside of our barbecue. But it was, if you remember, it was super windy that day.
Yeah.
Super, super windy. And so the smoke was not staying in the barbecue. It was going straight out. In fact, I had little tiny fires in my backyard because the chips would fly out of the barbecue.
Wow.
And they were just smoldering, right? So an hour later, I discovered this little tiny flame in my backyard. I think they'll smack that thing down.
Yeah.
But it was, it was too late. We were committed, so we had to finish it up.
That's cool. Turned out okay though?
Oh, it was okay. I mean, it was unevenly cooked because you couldn't keep the heat inside the barbecue. It kept getting blown out. So I don't know. Maybe if we could get a proper smoker, we would try it that way.
Yeah, that's cool.
But they're expensive.
They are.
Well, for the good ones.
Yeah, get a green egg or something like that. A couple grand.
Yeah, or even a Traeger, right?
Yeah.
You're looking at $500.
Yeah.
Let's see. Sorry, I still had music playing on my speakers.
Oh, nice, Jack. Yeah, I want to get a green egg super bad. I would love to cook in that.
Is it a barbecue or a smoker or both?
It's both.
Oh wow.
It's a slow cooker, barbecue, smoker. You can use gas, you can use chips, you can use anything. It's like, and it's super heavy, like
cast iron type thing.
Yeah, and so you put it in there and you close the lid and it just cooks. You can cook something overnight. Super safe. That's really nice. But that's the one that I was saying. It's like $2,000, $2,500 for one of those. Whoa. They're really expensive. Yeah. I spent $7 on my Weber. I was like, that's just a lot. But I wanted a Weber.
I think I spent $200 on my grill. It's one of those, after 5 years, you just throw it away, right? Because it's completely rusted through.
Yeah. That's cool.
But then the problem is, how do you dispose of that thing, right? Remember, it came in the box in about 200 pieces. You had to put it together, and now you have to take it apart into 200 pieces in order to get it back to the car.
That's right.
People on YouTube are like, what?
Yeah, what are you talking about?
So last week we introduced the final password cracking program, and I wanted to see how you guys are doing on it.
I got mine done.
Oh, wow.
I just finished this morning.
Awesome. Congratulations. Two questions. How long did it take in hours, roughly, to do the whole thing? And the second question would be, how fast does it crack, like, passwords out of the 3 million file?
Oh, you know what? No, I take that back. I got the video one done. The one that you created on the video, I got that done. I haven't done the other one yet. I still got to do that.
Okay. So you got
Mine maybe took like a cumulative 3 hours, and a lot of that was searching for a stupid mistake that I made. And then for the 3 million passwords, maybe like 5 seconds.
to do the whole thing, like load it all in, sort it, and then crack them?
Yeah, I think so. I'll run it one more time and I'll check.
Okay. I'm wondering, can we go into your account and maybe like look at it? Just so the people who are watching can get an idea about what the finished product looks like.
Yeah, that's fine with me.
Okay. Let's see, crack 3, right?
Okay, it took like 8 or 9 seconds for the 3 million.
Okay. So you've got 100 hashes. Oh, let's uncomment this and comment this. Am I in the right directory?
Let me look here. I have it under crack 3, and then crack C under crack 3.
Okay. Yeah, that's why I'm wondering if I'm in the right directory, because it didn't work.
Hmm. Yeah, when I did it, I didn't uncomment that 3M. I just used it from the files that I forked from the repository. So maybe I've done something wrong, but it's working on my computer, so I don't know.
Do you run it like this?
Yes. Well, yeah, I did. Let's see, I did just /a.out and then hashes.txt. Hang on one second.
Okay, so we do have hashes in there. That's good. This file looks okay.
Oh, maybe I'm running it wrong, because I actually had /a.out and then rocku3m.txt, and then I had a word in there, and I don't know why I was doing that. I was searching with the password, and it was working, and now it's not.
Now, I'm looking at it, and I run it, and it almost immediately returns. So I know that loading in the file and sorting it does take a few seconds.
Yeah, it's not. When I run it with the 3M, it definitely takes like 9 seconds, and then it finds them. I'm okay. I must be doing something wrong when I call it, because I just put /a.out and then hashes.txt and then I'm sorry, rocku3m.txt, and then I have the word password. I don't know why I was doing that, but when I take out that word password, it no longer works properly.
Well, how weird.
But try take out hashes.txt and see if it'll run that one. That's better. So I messed up something then, huh?
So it just could be this here, that read dictionary should get its file name from argv2. And then as far as opening the file for reading, this should come from argv1.
Okay,
So you've got a hard-coded hashes.txt in here. That looks better. So let's time it. Took about 8 seconds to run. So as you can see, the majority of that time is spent loading in the dictionary, hashing all the entries and sorting it, and then the actual cracking of the hashes takes just a fraction of a second. So you do all that work up front in order to be able to do the actual work, the actual results work very quickly. All right, good job. Looks great.
Hey, thanks. I gotta fix those 2 things, so I'll resubmit it.
Oh, this is going to take forever.
Well, I ran Valgrind on it, and I think there's some stuff, like I'm losing some memory, and I don't know why.
Let's do it on a smaller file. Can I do make clean? Will that work? Okay, so it says here at the end you have 2 mallocs that have used a total of about 174 kilobytes. And of those, you definitely lost one of them.
Okay.
So, and then here's the other one. Is you still have a link to this one here.
Okay.
So, what malloc would have allocated that much space?
Let's see. Oh, you know what? When I allocate space for the array, I started out small and then I add on to it as needed.
Yeah.
So maybe at the end of that, I'm not freeing it. But I believe I did free the malloc for the MD5. So maybe it's that. Maybe it's when I expand that array and then don't use it all. Is that?
Well, let's see. 174, 300. Let's divide that by 64. And there we get 2,723,000. Oh, and something. Oh, that's not 2 million. That's
2000.
2000. And it doesn't come out to be a nice round number here. Let's try 32. That doesn't come out to be round either. So what does an malloc of that size? Should we go take a look?
Sure.
So in your read dictionary, where's your read dictionary? Up here. So you do an initial malloc of, oh, you got size of entry. Okay, so let's see. How big is an entry? Let's take a look.
An entry would be, I guess, 33 plus 50, 88. Was that right? I don't know.
88. Or 83.
I'm sorry, 83, yeah.
2,100 of those.
Okay.
Okay, that makes sense.
So I started with 100 and then I do the realloc thing, but I'm sure there's there's got to be some left over at the end.
So you do an initial allocate of 100, and then if the capacity count is equal to capacity, make it 1,000 bigger, and then do a realloc. Okay.
So that just frees the hash frees the space for the MD5 right there, I think, right?
Let's see, where is your, okay, hashed.
Okay, so I need to, I guess I need to free the other. How do I do that?
So you don't want to free that up in read dictionary.
Okay.
If you do that, you'll lose your entire dictionary. So maybe in your main, so after you're done sorting, after you're done searching, after you're done cracking the hashes, at the very end, after you're all done, you'll do a final free of the dictionary.
Okay. So that's after print. Oh. Okay. Okay, if you just saved it, it'll be saved on mine, right?
Yep.
Or no?
Yep.
Okay.
All right, so that got rid of that one.
Okay.
Now you got one more that's 472 bytes. Now what could that be? 472 divided by 32? Nope. 64? Nope. So it must just be 472 bytes somewhere. Oh, 472, that's 472 divided by 83? Nope, it's not that. Ah, I'll bet that 472 is left over from a file that you opened that you did not close.
Oh, yep, you're right. I only closed one file. Darn it.
Go find that spot.
Okay, thank you.
And then we'll run it again.
Let's see. All right, I closed it. It's HT, okay. Okay, I've changed it.
There we go.
All right, thank you. My dumb mistake before was putting, when I was doing the typedef struct, I did hash of 30 instead of 33, and that cost me like an hour and a half of wondering why I wasn't doing it right.
So stuff overwriting each other all over the place. Huh?
Yeah, always some mundane detail.
Let's see, Ben says he's finished. Took about 5 hours. Of that, some of it was spent chasing down silly mistakes. You know, they're not really silly mistakes, I guess. They're learning. And, you know, do they have to do with pointers? They probably
For
do.
me, it was just like the structure of the program. Like I accidentally, instead of having it where it brought in a dictionary file and the hashes file, I was testing it with the hashes and with the hashes.txt and the passwords.txt. And I was basically taking those two files and taking the passwords from one and the hashes from the other and putting those into the structure instead of loading the dictionary and then hashing the dictionary.
But it's all working now?
Yeah.
Good.
I ended up using struct pointers instead of like the struct array.
Let's see.
It's in the
I'm looking at
CS
Jack's
project.
I'm looking at
Oh.
Jack's comments here. Has trouble with the reallocation of space. Okay. I'm just taking a quick scan here. All right, I think I see an issue. Why don't we let the other people look at it? Tell me if you see anything kind of sus in here. All looks okay? So I have to tell you, when I was looking at this, what I was looking for is just something that would jump out at me as maybe a little dodgy. And particularly since Jack said he had something to do with the reallocation of space. So I kind of focused my attention around there. And he's got a comment down here that says there's a core dump causing a problem of realloc happening. So yeah, kind of look in that area and see if you see something that looks a little weird.
Oh, there's the indexes on the element of an attribute of pass rather than pass itself.
Which
Plain pass, yeah. It's not modifying pass or on an index of pass. It's on an attribute of pass.
So is pass an array and plain pass is a string?
Plain pass would be a string.
Let's go look at the struct here. Yeah, plain pass is just a character pointer. So when we do this,
at that particular thing, it would try to pass. It would try to pass a string into the location of one character dereferenced, and that doesn't work.
And pass struct entry pass equal to malloc 100 times size of character pointer. So pass is supposed to be the array of the structures. Is that correct? Yes, Jack says. So that means this should not be a size of a character pointer. This should be a size of something else. What should it be? So this should be, since this is supposed to be an array of struct entries, then here we should put a size of struct entry so that it can be an array of 100, you're allocating space for 100 entry structures. And let's just make sure when you do the realloc that you've got the same thing down there. All right. And then, I don't remember who was talking, maybe that was Ben who was saying, this here, this bracket I, should be an index into the pass array. Same thing down here. Yeah, by putting the array indexes on the end, then you're indexing into this plain pass string, which is probably not what you want to do. You want to index into the pass array. Okay, let's try this out. Oh, looks like Jack was editing it also, so I'll go ahead and overwrite it. Okay. And then these, you don't need to dereference str because it's already a pointer, and that's what we need to assign to plain pass. So these need to be just plain old pointers. Let's see, struct entry is not a pointer. Did you mean to use dot? Oh, yes, we did.
Because it's already dereferenced with that indexing I, right?
Yeah, and because every single entry in the array is an actual structure. It's not a pointer to a structure.
Ah, okay.
Okay, we got it to compile. Still dumping core. Let's see where that's happening. So it's happening in read dictionary at line 40. And this is line 40 right here. So there's still something dodgy going on in your realloc here. No, this condition looks okay. This condition looks okay. So problem is happening on this line right here. Now that I've focused your attention on that line, what do you think is going on here? What is the type of size? We can go back up to the top of the function and find out. What is the type of size?
It's a integer pointer.
It's an integer pointer. So what happens when you add 10 to an integer pointer? Does it increment the value it points to?
No.
No.
What does
Should it be
increment?
star size?
Yeah, it should be star size. What is it actually doing?
Copying it.
No?
Bumping up the pointer by 10.
Yeah, it's changing the address that it points to.
Oh.
Well, it's changing the address of the pointer, and now it points to something else. It points 10 bytes further than it did before. So it's no longer pointing to the value of size. It's now pointing to something else. Still crashing at line 40. I'm going to run that again. Let's see, let's print the value of I. It's 0. I guess that's reasonable. Let's print pass. Oh, pass is a null pointer, and that's going to cause a problem when we try to index into it. And then str is an empty string. Okay, so we got some issues going on here. So str is an empty string. Let's see, we should be copying word into string. Word should contain a word from our input file. And Jack, don't forget to check to make sure it actually opened the input file. So there needs to be a check here. Okay, and so the value of I is 0. Why is that happening? Well, let's see. We get the word, strip off the new line, allocate space for the word, copy that in, and then this is an error here because pass for some reason is null. And then here we do reallocation. We pass in pass, and we pass in size times size of struct entry, which is okay. So you know what I'm going to do? I'm going to do a little bit of print debugging. Let's do this. Printf I is equal to %d. Word is equal to %s. Actually, let's do this after we strip off the new line. Okay, well, look at that. So it's not that I is not incrementing. I is, in fact, incrementing. It gets all the way up to 107 before it finally crashes. Word is not actually words to the dictionary. The word looks like hashes. And it looks like Word got up to, 8F, 9, and then it started repeating. And then these started repeating. So once we got up past 100, then we started kind of having a problem here. So if we look out in our main, and we called read dictionary, we're passing in argv1. Now argv1 is supposed to be the name of the hashes file. argv2 is the name of the dictionary file. Okay, so that looks better. Now you got your words here. But still, once we get past 100, once we get past, 159 or so, I'm looking here because, look at this right here. Alexandra is the last word. I know that's at the end of 100. And then it looks like we kind of start all over again. If you recognize these are the first words out of the password file. Which one are we using? We're using RockU 2000. So I know there's obviously some other issues going on here. I'm a little confused as to why it starts to repeat itself instead of continuing on.
Shouldn't you use a separate variable when reallocating the space? The size is meant to have the size of the array, correct?
Mm-hmm. So one thing I do see here is that we got a loop going from 0 up to this size, which when you're first calling this function, you actually don't know what the value of size is. You don't know how many entries there are going to be. So you really can't loop from 0 up to the size. What you want to do is loop until you hit the end of the file. You're just reading in words out of the dictionary file, and you're done when you hit the end of that file. And then you know what the size is, because you've been keeping track the whole time. So this actually needs to be a while with an fgetS in it. Then you can use I to keep track of where you are in the array, and you can use size to keep track of how big the array actually is. But whoever said that before, I think it might have been Ben. So you need probably 3 variables here. You need one variable to keep track of where in the array you currently are, where you're inserting entries in the array. You need another variable to keep track of how big is the array altogether. And then ultimately you'll need a third variable to keep track of how many entries are actually valid in that array. And it could be that the first variable, the I, and that third variable are actually the same thing. So I guess you only need 2 variables. You need one variable to keep track of what's the actual valid size of the array, and the other variable to keep track of what's the total size. Because the total size is probably going to be bigger than the actual size, or the amount of valid entries.
Yeah, so like every single time you read in a line to the word variable, then you'd want to increment size, and then you could have like another one as the capacity of your structure array.
Yeah. So when we were doing our Pokemon, no, was it the Pokemon? No, it wasn't that one. Which program was it where we actually loaded in the dictionary? Load words. I'm looking for the one where we actually use the word capacity. Oh, this was the linked list. Don't want that one.
I think
Here
it's
we go.
2.
There we go. Number 2 here. So open the file for reading. You've got an initial capacity. So capacity is how many it could hold. And then you do your initial malloc. Then you start this loop. And this is how you go from the beginning of the file to the end of the file. Trim off the new lines, allocate space for the word, put it into the array, and then expand the size of the capacity it needs to be, if it needs to be. So you might want to take a look at the video where we went over this particular program. This was maybe from maybe 2 weeks ago. And this will show you how to load words into a dictionary. Now this one just loads it into an array of strings, right? So you have to modify it slightly to work with your array of structures, but the main part of this, the main concept here we're learning about is how to, where is it? How to loop across the whole file, how to copy the word in, and then how to expand the size of the array. And then couple that with the entry or the program we wrote about the Pokédex. So there we loaded in the, where is it? Load Pokédex, right? We did not have an array that expanded itself. We just allocated space for 10 of them. However, we did we did use these two variables to keep track of the size of the array and how many entries in it are actually valid. So you kind of have to take pieces of both those programs and put them together. Okay, so I will let you work on that some more, but you're on your way. Now this is not going to compile because of this line that I stuck here. Interesting that I went from 389 back to 0. And it's probably because you're looping from 0 to star size, but you're changing the value of size as you go through the loop. And loops don't like that so much when you're changing the ending condition. So change that to an fgetS and then increment I in size separately. Okay, and then Ben, so you got yours to work?
Yeah.
Okay, good. All right. Well, let's see. We got one more program to write for this semester. Yay! And then we're almost done. Then we're done, right? So I wanted to kind of introduce the idea of computer networking to you. We can write a program that communicates with another computer. So you can write a program that can send data to another computer and can receive data from that computer and do something with it. So this is called client-server programming. In this style of programming, you have a program called the client, which runs on one computer. The client is a program or a computer that makes a request. And you have another computer called the server, and it's running a program that fulfills the request. So it's kind of like walking into a store. You're the client, the customer, walking into the store, and inside the store there is a person, a server, who is there to do whichever you ask. So you walk in the store and say, I'd like to buy a shirt. And the server says, okay, let me go and get one for you, and goes in the back room. Maybe it's a shoe store, right? You go into the back room, finds a shoe for you, brings it out to the front, and then you buy it, basically. So the client is the person who initiates the transaction, and the server just fulfills that transaction. Every computer on the internet has an address. It's called an IP address. IP stands for Internet Protocol, and protocol is a word that means a set of rules for communication. So when two computers want to communicate with each other, they have to obey some rules about how to format the data, how to send data, how to receive data, so that both of them can communicate with each other. So I want to take a step backwards and do a little demo of something that I think is pretty interesting. So way back in the old days of computers, if you wanted to connect to the internet, or at least connect to some other computer, you had your computer connect to a device called a modem. And that modem would have looked something like this, or they would have been a little bit bigger. It's got some lights on the front to tell you about the status of the modem, and on the back you've got these ports to connect to your computer. This one here is called a serial port. It's got 25 little holes, 25 pins, of which you actually only use about 6 of them or so. And it's got a couple more jacks where you would connect your phone line. So you would connect your, what am I looking at here? You would connect your modem to your computer, and on the back of your computer you would have a port called the serial port. So on the back of a typical PC, it's a 9-pin connector, And on the back of a modem, usually it's a 25-pin connector. So you would then need a cable that had both those connectors on it. So one 9-pin connector for going in the back of your PC, and one 25-pin connector for going back in the back of the modem. And so this would just connect in like this, and then this would go in the back of your PC. You would also add a jack here for applying power to it. You've probably heard in the movies those screeching, squelching noises that those modems make when they would make a connection. But once they made a connection to their computer, you could then send data back and forth. Now these days, very modern computers and most laptops don't come with those serial connectors anymore, so you have to get one. And these days you can get a USB cable, so obviously a standard USB connector. I got to move out of the frame here. And then on the back of this, or the other end of this, is one of those 9-pin serial port connectors. So this is a way to add a serial port to a computer that doesn't already have one. And then you would just plug in this cable here, and then this end would go into the back of the modem. Now the other problem to do this demo is I don't have a phone line anymore. I don't have one of these standard phone lines. I only have my cell phone. And also, these days, there's no one to call. Like, even if I could connect this up to a phone line, a standard phone line, and then make a call to some other computer out there that had another modem that we could talk to, there's just no one out there anymore. So this is the old, obsolete technology that no one uses really anymore. I could still send a fax with this, but that's not what I'm here to do. So you can buy these USB serial adapters, or you can also buy one where the guts of it are exposed. And that's what I have here. So it's just a little circuit board. We're going to move out of the frame here again. Come on, is it going to focus? There we go. It's got USB on one end, and it's got, well, in this case, what, 5 or 6 pins that would attach to that 9-pin connector. And then all I have to do is plug this into my computer, and I've got a serial port, but I've got these exposed pins where we can look at the actual signals that are coming out of it. So I'm going to go ahead and do that. I'm going to plug that into my laptop. Actually, before I do that, I have here, this device is called an oscilloscope. The purpose of this device is, and then you probably have noticed that there's a there's a blank spot in my background where that oscilloscope used to live. So right now it's down here doing this demo. So this is an oscilloscope, and the purpose of this device is to measure voltages and plot them over time. So along this x-axis I've got time, and along this y-axis I have voltage. And right now, of course, it's showing nothing because nothing is plugged into it. This is a test probe, and I've got nothing plugged into it. But I'm going to attach it to this so that we can see the actual bits being sent. Okay, so what I'm going to do is, I've got these connectors here, and I'm going to put one of these wires. You have to have at least 2. So one of these is labeled ground, so I'll put one there. And then I'm going to use another wire here, and I'm going to attach this to the transmit pin. It's labeled TX. And then this one here, I've stripped off a little bit of insulation so I can attach that probe to it. Nice thing about these serial ports is you didn't actually have to connect them to another computer or a modem in order for them to work. You could send data to these things, and then they would make the voltages appear on the pin regardless of whether there was actually anyone listening. So we'll be able to actually see the 1s and 0s being sent. So I am now going to hook this all up. So I'm going to attach this lead here to the ground, which for me is the green one right here. And then I'm going to attach the other end of the probe I've got all my wires tangled up. I'm going to attach the other end of the probe to this little stripped off portion right here. It just hooks on. There we go. And now I have a little USB extender, so I'm going to attach that here. And then I'm going to plug it into my laptop. Okay, so now we've got a power light on there indicating this has power. And you probably also saw that this line moved up. So when I did not have it powered on, let me unplug it again. You can see the line is down here, and so this indicates that there's no voltage coming out of this device. But as soon as I plug it in, that pops up. Now the way you read these divisions is each one of these divisions represents 2 volts, the way I've got it set. So 2 volts per division. So here's 0, here's 2, and then up here is 4. So right here we're about 2/3 of the way up between 2 and 4. So this actually represents 3.3 volts, which is one of the logic levels used in computer communications. So how are we doing so far?
Cool.
Okay, so I can now come over to my computer over here. And I can make, so on my command line, I can make a connection to that serial port. Now, if you're on a PC, you can plug one of these in. You can use a program like Putty to do the same sort of thing, but I'm on a Mac, so I'm going to use my command line here. I've got a program called Minicom. So now what this is showing is what this is showing is basically a connection to that serial port. Now nobody's listening to what I'm typing, but when I hit a character on my keyboard, it will send that character down the USB line to that little device, and that device is going to turn that into the 1s and 0s that will actually get sent across the wire to another computer or a modem if it was listening. But nothing is. But we'll be able to see it anyway. We'll be able to see it. So here's the oscilloscope, and I'm going to hit some keys, and you can probably see them flashing by. Right? Did you see them?
Yeah.
Right, so if I just type a whole bunch of stuff, you can see those 1s and 0s going. So every time it comes down to the bottom here, that's a 0, and anytime it stays up here, that's a 1. So when you're not sending anything at all, this is called idle. It's just sending a 3.3 volt signal down the line, and it lets the other computer know, or whatever's listening know, that there is an active signal on this line, but nothing is being sent. And then as soon as I hit a key, you can see those 1s and 0s start appearing. All right, so they flash by, but it's really hard to see them. So you can put the oscilloscope into what's called a single trigger mode, which means instead of watching the signals go by, as soon as it sees a signal, it's going to pause it, and it's going to capture what it sees. So all you got to do is press this button here that's labeled single, and then I will press a key, and it captures the 1s and 0s. So I can take a screenshot of that and put it on my iPad so that we can look at this. So this is what I just captured. Okay, so over here, this is the idle, and over here, this is the idle. Now, the actual data I sent starts here, and it goes all the way to here. So it's a little bit beyond the very end here. So when you send data down a serial line, the problem is, a fundamental problem is that the receiving end doesn't know when that data is going to start arriving. So what it's listening for is something called the start bit. And that's the first thing that we see here. It's right here. The signal goes from idle down to 0, and that lets the receiver know that data is going to start flowing. So that first start bit there is just a little signal that says, hey, the next bits that you see go by are, in fact, the data bits. So that's the start bit. And then we've got here a 1, a 1, a 0, a 1, 0, 1, 1, 0. And then it ends with a stop bit when the data returns back to idle. So look here, we've got 8 bits of data. Now this data comes in reverse order. This is the least significant bit, and this is the most significant bit. So it's backwards. Serial data gets sent a least significant bit first, and then it goes up to the most significant bit. So in order to read this, we need to flip all the bits around. So let's just reverse everything. And we get 0, 1, 1, 0, 1, 0, 1, 1. So I just took these bits and I reversed them. And then in hexadecimal, this is 6, and this is B. And actually my oscilloscope already understands this, and it already decoded it as 6B. So what is 6B? Well, to figure that out, we have to look on an ASCII table. And we'll look here under the hex column. 6B is right here. And you can see that is the letter K, and that is in fact the key that I hit on my keyboard. I hit the K, and I got that. You want to do another one?
Sure, that's neat.
All right, so we'll go back to our oscilloscope. We'll put it in single mode. And I'm going to hit a key, and then maybe you can try to figure out what that key was. So let me grab a screenshot of that. I covered up the answer, so you can't just see what it is.
That's what I was waiting for. 0, 1, 0.
All right, but it shows you that it starts here, and it ends here. And remember, we've got a start bit, which is not part of the data itself, and we have a stop bit here, which is also not part of the data. So the valid data is here to here.
But why?
Close.
Do wrong.
Tiffany's got it.
Oh, yep.
We got 0, 1, 0, 1, 1, 0, 1,
Yeah,
0.
I added that wrong.
And if we
It was
flip
60,
them
not
around,
59.
we got 0, 1, 0, 1, 1, 0, 1, 0. And that is
5A.
the letter Z.
Yep.
Capital Z, to be specific. "5A," right there. So that's how
Oh, yeah.
computers sent data to each other. Is they just wiggle the voltages up and down, and like a 0 means 0 volts means a 0, and then a positive volt means a 1. And that's basically how it works. These days you have Ethernet connectors, which go at 10 megabits or 100 megabits or even 1,000, and now they're almost up to 10 gigabit as far as affordable for consumers. And so those voltages are wiggling up and down, millions or billion times a second. You can actually, look at them with an oscilloscope, and you can decode the ones and zeros out of them and read the data. So if you have physical access to an Ethernet cable, you could clamp on a little device that'll read the data going back and forth and decode it. That's why these days a lot of data is encrypted, right? Because someone could just snoop on the line and read all the data going through. Same thing with Wi-Fi, right? Everything's encrypted on the Wi-Fi. Otherwise, someone just needs a radio and a specialized radio, and they can listen to all the traffic going by. So when you want to send data on the internet, it assembles all those bits into what's called a packet. And the packet consists of, now it's not really two-dimensional like this. This is actually one long array of bits, but it's stacked up into 32-bit quantities, so it's easier to see. But each one of these fields has a meaning, and like there's total length, so this is the total length of the packet. Again, the receiver needs to know when the data starts and when it's going to end, and so it needs to know what the total length is. It's got a fragment offset, so it knows like what order the packet's coming in. First packet going out is number 1. Second packet going out is number 2, 3, 4, and so that's how it knows if it's missing a packet, if the numbering then jumps ahead. And then we've got checksums used to verify whether the data is all correct or not. And then finally we've got source address and destination address. Those are those IP addresses that I just showed you, or about where the machine that it's sending from and the machine it's sending to both have IP addresses, and that information is included in the data packet. And then following that are options in the data itself, and you can do up to 64 kilobytes of data. So if you want to send something that's bigger than 64 kilobytes, you have to break it up into smaller packets. Basically, you're going to chop it up into pieces, and then you send each one of those pieces separately with a different fragment number. And then the receiver receives those packets and reassembles it back into the original data. And then if it misses one of those fragments, it can go and ask the sender, please send me fragment number, let's say 12 again, and then the sender can send that back and fill in the gaps. Any questions about that?
No, that's neat to see how it's all broken down.
There are a great series of videos on YouTube by someone named Ben Eater.
Yeah, you showed us in discrete structures.
But I just recently watched his stuff on networking.
Did you know there's a ransomware attack every 11 seconds? VMware Cloud Disaster Recovery helps you recover faster.
I want to pause this. This one here is good clock synchronizing and Manchester encoding. and then analyzing actual Ethernet encodings. So these two, this one here also, the very first one, this one, and this one are great for showing you actual Ethernet packets.
That's cool.
I could reproduce that myself, but I figured he did a great job, so go watch those videos.
Mm-hmm.
Okay, so we got a few minutes left, but what I wanted to introduce you to this idea that I have set up a server for you to access. This is its name, fremont.cs.sierracollege.edu, and this is your virtual machine running on our server, and you can make a connection to that server. You also need to supply not only the name of the server, but also its port number, and you can then interact with this server. So this one is really simple. You connect to it, and it says hello, and that's it. So it's kind of like walking to a store, and the person at the front door just says hello, and then that's the end of the transaction. You leave at that point. You probably know that there are some well-known port numbers. Got like 80 for doing web traffic, 443 for doing secure web traffic or encrypted web traffic. You got 25 for sending email, and 22 for doing terminal, secure shell terminal, which is the command line stuff. Anything else that's outside of the well-known port numbers, you can just make your own services, and other people can connect to them. You're probably familiar with, you can go into something like Minecraft, and then you say open to LAN, and then it gives you a port number. And then anyone who knows your IP address and that 5-digit port number can then connect to your Minecraft server and play along with you. Jack and Ben are saying 25565, right?
Oh.
Yeah, but if you like do it in your home network, that number just changes. It's a random number. And that's kind of like, this is the bane of my child's existence, because he always has to go, Dad, the port number is 58216. And then I have to go into my router and change the information there so that his friends that are at their homes can connect to his server. And then every time he starts a new world, he has to go, Dad, the new number is 68217.
That's funny.
I wish there was a way to get it to always stick to the same number, but it never does. It picks them randomly.
Yeah.
All right, so we're done with this. Hold on here. So I can use a program to make a connection from my computer to that Fremont server on port 2345 and see what it sends. And I can do that right over here. I can go ncat fremont.cs.sierracollege.edu 2345. And we can see that, all it says is it sends a greeting, but in some random language. So we can write a program that will do the same thing. It'll be a C program that establishes a connection to 2345. It then receives that data and then displays it on the screen. So I think what I want to do, since we've been at this for an hour and 15 minutes, is we could take a little break. And then if you want to, we can come back and write that program.
Yeah.
So it's, we don't really have a lab assignment yet. We'll do the lab assignment next time.
Okay.
All right. So let's take a little break. Go up, stretch, get something to drink, go to the bathroom, and then we'll come back in about 10 minutes.
Cool.
All right.
Sounds good.
I don't yet have a graphic for Be Right Back, so I have to make one. You know, my son's been trying to get me to buy Minecraft Realms, and so I don't know much about it. As far as whether you can... I mean, Minecraft Realms, isn't it like a... It's totally different. There's Minecraft, the Java edition, which is a very original version of Minecraft. It was written in Java, and then once they wanted to start porting Minecraft to other platforms, like PlayStation, Xbox, iPad, you can't write it in Java anymore, so you had to port it to the native programming language or native processor of that particular platform. And so that's where I think they came up with this Minecraft Realms, I'm guessing. These are Minecraft 2nd edition, right, that works on the different platforms. And now they got what? Minecraft Realms, they got the Minecraft like storytelling version, Minecraft educational version, which can be programmed using Python. You can only get that for the Raspberry Pi. Although, I mean, it's available for Raspberry Pi, you can also download it for other Linux distributions. But the cool thing about that is you can program it in Python. So it's a great way to teach kids who are used to playing Minecraft a little bit of Python programming. You know, you can write a loop to spawn, 1,000 chickens very quickly. So you don't have to click 1,000 times. Just boom, there's your 1,000 chickens. Oh, Realms is just a server host that Minecraft makes? Oh, okay.
Yeah, I pay for Realms every month, and it's like $10. And so I was wondering if maybe I could stop doing that.
Well, I mean, there's... Oh, that's true. Illuminate my kids saying, Dad, the new port is 8943. That's true. I was thinking about that. But it's easy. He already knows how to like create his own server or create his own world on his computer and then, just open it up when he wants to.
And he doesn't pay for Realms? Oh, what the... All right. But you have to create a new world. Is that true every single time? Or?
No, you can open up an existing world.
Existing world.
Yeah, and then you just have to go onto your router and say, I want to forward port, whatever that is, onto my local machine on that port.
All right. Well, I'm going to cancel my Realm subscription then. I've been paying for almost a year now. I'm upset.
I got a quick question for you that's kind of off topic.
Yeah.
In Bash, to access C program, like with Python, it's user bin Python 3.
Mm-hmm.
For C, is it just user bin C?
What do you mean?
So when you're coding in Bash,
right?
Yeah. You have to tell it where to go, right? How to find. So like when you write a Python code, the first thing you do is at the top you do the hashtag exclamation user bin or bin user Python 3, right? So if I want to write a code in C,
you just run the executable. The reason why you have to do that in Bash is because the Python interpreter is one program, and then it reads in your script file and executes that. But in C, because that's compiled, all you have to do is just say / in the name of the program. runs it.
But if I want to write it in like Pico,
Mm-hmm.
I just write it in. I don't have to do anything special.
No,
Oh, okay.
no, you just compile it. All you need is a text editor. Pico is a text editor.
Yeah. Okay. Cool. All right.
Yeah.
I think I'm gonna do my final in that class. Part of it in C. That's what I was asking.
So our environment is just a fancy graphical editor, but you could use Pico to do exactly the same thing, which is what I did when I was in college. I did all of my editing on the command line, all my running and compiling.
It just feels good
Yeah.
doing it on there. I think because it's older and it's not all the fancy stuff.
Mhm.
Yeah.
I think your confusion is a common thing that I see among students, which is it's difficult to separate the IDE from the language.
Yes, it is.
So
I
I've had students come into my CS13 class and go like, I don't know how to program Java in Eclipse because I've only done it in JGrasp.
Mhm.
Well, I can understand you might not know what buttons to click, but it's the same Java.
Yeah, the code's the same.
The code's
I
the
just
same.
didn't know I didn't know how all that worked when you're coding in there. Because with the, I figured the code would be the same. Because we started doing Python a little bit, and it's the same thing that we did in discrete structures. And so I get the code's the same, and that made a lot of sense on how it all works together. But I didn't know if it had to be told where to find. I'm assuming that top hashtag. What do you call that? The hashtag. The shebang.
Yeah.
All right, that top shebang. I'm assuming it's telling the program where to go to get the information to run the program. Is that what it's there for?
Almost. So when you launch a script file from Bash, what Bash does is it loads that script file in and it looks at the very first line. And the first line is one of those shebang lines, the hash mark, and then the exclamation mark, which is pronounced shell bang, right? Bang is exclamation mark.
That's why it's
the hash mark
shell
is
bang.
called shell, so it's just run together, shebang, right? And then what's after that is the name of the executable to actually run.
Okay.
So, like for Python, it's shebang user bin Python, and so Bash says, okay, I'm not going to run this program. I'm going to run Python 3 instead. And then it will pass in the name of the script file that you just ran as the first command line argument to Python.
Okay.
And so what it then
Gotcha.
is it launches Python, and then Python knows to grab the name of the input file from the command line.
Okay, and with C, you don't have to do that
You don't
because
see, you don't have to do that, right? Yeah. Not at
Okay.
all.
Okay, cool. Well, that's easy. Cool.
Now, if you want to do your editing in Pico, that's totally cool. If you want to be all like fancy and stuff.
Yeah, I like Pico. I like Vim. It's just I got to get used to it. I don't push I, and then I end up messing things up, and I don't know all the keys to it yet. And so when I start doing things on my own that aren't worth grades, then I'll do that. But for now, I just use Pico and Nano.
I mean, here's something you could do: is you could launch Visual Studio Code on your computer, and then you go and install these remote SSH editing and remote control extensions and remote development.
Okay.
And then you can come over here and let's see, how do I do this? It's been a while since I've done this. I'd have to look up how to do it, but basically, it's been a while, like I said, but basically, you can then open up a Visual Studio Code session that has created a connection into the Linux server. You can see all your files. You can edit them in your Visual Studio editor, which looks just like Thea. You can open a terminal and run stuff there.
Wow, okay.
And so it basically allows you to edit locally, but save all your files on a remote server.
I'm going to have to look into that. Community 2022. I'll have to do that a little bit later. That's neat.
Now I have to refresh my memory. How do I do that? New file, that, disable, close all editors. No, don't want to open a new file. Golly, now I'm embarrassed now that I don't remember how to do this. Oh, here we go, Remote Explorer. That's what it does. Enter password.
Oh, that.
Here's all my stuff.
Yeah, how long this takes? 10 gigs to install.
Is it? Really?
Yeah, yeah.
For the remote SSH or the remote development?
No, for Visual Studio.
It's 10 gigabytes for Visual Studio Code? Not Visual Studio. Visual Studio Code.
Oh no, I'm downloading Visual Studio.
Oh, that's not what you need. You want Visual Studio Code.
Ah, I see. Yep, I wonder how I cancel this.
What do you have to download? Just Google for Visual Studio Code. And then you'll end up on this website, code.visualstudio.com.
Yep, I'm on there and I'm downloading it. In fact, I think I just got done downloading it.
So we go to the extensions manager, which is over here, and then search for remote. And this one here, remote SSH.
Remote develop over SSH.
This one here, remote SSH.
And that's on the website?
No, click on extension. Once you run Visual Studio Code.
Oh, I see.
Then you go to the extensions manager.
I just came back a couple minutes ago. Are we downloading this for the last assignment or something?
No, Terry was interested in how can he get, he wants to do his final exam in his Linux class. And I'm showing him that you can use Visual Studio Code to access your files on that remote server.
Okay.
So no, we're still on break.
Which Linux class are you in, Terry?
50? CSCI 50?
Oh.
Okay, yeah, I'm in that one too. Who do you have?
Delphine, I can't pronounce his last name.
Okay, I have Tim going.
Oh, okay. Yeah, I think we were talking about that. It's like super different.
Yeah, it's way different.
No, it hasn't been hard. It's actually been, I guess if you've taken 12 CSCI 12 and 13, it's really easy. It's
Yeah, a lot of the stuff we're doing on on Thea kind of carry over.
Mm-hmm.
Oh, someone says it asks for a connection command. If you create a new connection, then just like kind of do what it says here. You go SSH and then your username, joe@cs. Sierra College ID, and I guess it asks you to put a dash capital A on the end.
What is it that you have to do for your final project?
We get to pick our own, and so I would take it, John. I think it would be helpful. We get to choose our own. We got to write up a big old paper for it and then develop it, and he tries to get people to work together, but my time's crazy, so I don't have people to work with. But anyway, mine's going to be a program that pushes get files and creates a local database to keep track of the date, the comments, basically everything that would be kept on the Git repository, but keep it locally. And then giving options to search through it all. Look to see what's, you can look at the dates, you can look at the comments, you can get rid of the comments, you can see whatever you want to see. And I'll use C and Python and SQL and AWK to do it all.
Wow, that's impressive. That sounds actually pretty useful. Like a little like Git manager.
Yeah, keep it local so you can look it up real quick without getting online.
Yeah, totally. That is really neat.
Thanks.
Does all this stuff run on the Linux server that we use for class?
Mine will be, yeah.
That's cool. When you do the who list and you see all the I see your name on there every once in a while. I was like, oh, I wonder if there's.
Yep. Yeah, it's been fun. So my professor, he's good. He's super smart, but he's I think he's from the Dominican Republic, and he's got a really heavy accent, and so a lot of times it's hard to understand what he's saying. But he's got really good PowerPoints that I've just every time he shows one, I just download it and keep it. It's super thorough, and so I use that to try to get through everything. But he's good. I've enjoyed it quite a bit. You hear about all these different languages, and for somebody that I'd only done Java before this class, and a little bit of Python and discrete structures, but mostly that was Professor Brown writing the programs for us, and then we just added a little bit here and there. And so, you hear about all these other program languages and how different they are, if they're hard to learn, and right, because it's like another language that you speak. So seeing all of that stuff and seeing how it's actually really easy was really nice.
So wait, you're using it all in this class. You're using not just regular shell scripts, but you're using. I mean, we used a little bit of C and R's, but you're going like Python and SQL. Like that's Is that stuff that he covers in that class?
Mm-hmm. Yep. Yeah. Each week we basically get a crash course in everything that, right, all of the basics of a language. So like
Wow.
loops and conditionals and how to create variables and how to 13, 39, 50 and Calc 2, as well as work on 30 to 40 hours a week. I don't know. That's probably not a good idea. Yeah, it's a little bit of everything, and it's been really neat. It's been a lot of fun going through all of it. Seeing how I love databases. I like accessing them, and I like, in fact, over the summer, my program that I wrote in Java was kind of a database. It's pretty rudimentary, but kept all my, I like to cook also, so kept all of my recipe files, created files, and I can print them and sort through them and all that stuff.
Nice.
But I just like databases. So being able to get into AWK and SQL, that was super, super fun. So this actually tonight, I have his classes at 6, and we're gonna go over how Python can be used to create databases. And so that'll be fun.
It does sound fun. You guys using SQL primarily for the databases?
To create them, we did, and then we used AWK to kind of pull out what we wanted to see.
Mm-hmm.
But yeah, when we created databases, it was SQL.
That's cool. You get like 2 different classes in one.
Yeah, it's nothing like this. I mean, this is like, this class, you get really in depth and stuff. With that class, it's just kind of a touch on a little bit of everything.
Mm-hmm.
So. Yeah, John, I did kind of backwards. I did all of my CS stuff first. So now I've got Calc 2, both of my physics, and then a buttload of history and communications. And I think I got an economics class and all that stuff I got to do. Yeah, 50, if you get a chance, 50 is really cool, especially after taking this class. It's going to be really fun. Do you still teach that?
50?
Mm-hmm.
No.
No?
I haven't done that for years. But almost all the curriculum from Delphin's class is mine.
Oh, really?
Yeah.
Okay.
I think so. He has to do like little worksheets where you fill out the commands.
No.
No? Oh, maybe he's totally changed it.
No, he gives us a Word document,
Mm-hmm.
and then we program it, and then we take screenshots and post
okay.
it in
That
the
is
Word
different.
document.
I used to give just worksheets that had like 50 problems on it.
Yeah, our labs are huge. They're like,
what command would you use to print the date? What command would you print to do like just the year, just the month and the date? So
at the beginning of the semester, we had that.
Oh, yeah, those were mine.
Yeah, we had. Okay. Once we started getting into the different languages, then it was write a program that does this. And then each one you add something else to it or make it do something different and take screenshots and put them on there.
Well, let's quickly write this program that's going to connect to our server and then get the greeting from it, display it on the screen, and then quit. And then when we come back after the break, come back on Tuesday, then we'll learn about some more complex servers that I got set up that you can do two-way communications with them. And then we'll learn how things like email gets sent, and then we'll get into the final project. Final assignment. So it's not really a big assignment. It's fairly small.
John wants to know if you're going to teach 13 next semester.
No, I'm going to be doing these 2 classes for at least another year. Just because we're still online.
Yeah,
it's just easier for me to manage 2 classes than 3.
Okay, so not spring and not fall of next year.
Correct.
Damn.
Sorry.
Okay.
Okay, so when you are writing C network programs, there is a built-in library called the socket library. And you can imagine, the reason why it's called socket is you can imagine you've got like, you know, a outlet over here, and you've got an outlet over here. And, you know, these are electrical sockets, and so you can run a wire between the sockets, and that's kind of like the idea of a connection going between two computers. So that's why it's called the socket library. But it's kind of hard to use. It gives you low-level access to the underlying routines, and for beginners, there's a lot of boilerplate code that you have to write just to get your connection going. And so fortunately, some people have written wrappers for the socket library to make it easier for a beginner to get connections going. And so that's what we're going to use on our programs. We're going to use one of these wrapper libraries. And a wrapper basically is a set of functions, or in the case of like Java, a set of methods and classes that someone writes in order to wrap up or hide the underlying libraries, the underlying code that's going on, and hopefully provide an easier interface to it. It's kind of like how the array list class in Java is a wrapper for the actual underlying real arrays. And it gives you some nice features like the ability for it to expand and for you to do things like search, which underlying arrays don't have. So in order to get this library up and running, you need to compile and install it on your workspace. So if you go into our first assignment, which is level 12, measuring round trip time, it tells you how to install this libsocket library. And you just follow the instructions. So that's what I'm going to do here. So we're just going to copy and paste these commands. Okay, so those 4 commands have downloaded the source code, compiled it, and then we need to install it. Just copy and paste these next commands. Oh, this last one I need to fix. It's not entirely correct. Yeah, just cd tilde. All right, I need to fix that. Okay, so when you compile your programs, you just need to link into the socket library that we just built. So you just need to do a -l socket when you compile it. Okay, so let's write this.
Oh, that's a capital I.
What is that?
Capital I.
Where?
On ID config.
Oh, LD config.
Oh, LD.
That's why I was just highlighting and copying and pasting, just so I get all the characters correct.
I like to type.
Ah.
It helps me remember.
Yeah, so what this does is since you install the new library, you have to tell the loader about this new library. And so that's what this program does. Because what happens is the loader it learns where all the libraries are, and then it doesn't, in order for speed, it doesn't scan those directories every time you run a program.
Gotcha.
So you have to tell it, rescan those directories, learn where all the new libraries are, and then it caches all that information.
Okay.
Okay, so we're going to write this program. So include standardo.h, include standard lib, and we also need to include I think it's libsocket.h. And let me just make sure this compiles. Clang get hello.c-l socket. Nope, that wasn't the name of this library. I very conveniently forgot to write that information on my notes.
We looking for an H file?
Yeah.
Is it in the libsocket directory?
No, it is. Well, since we installed it, we should be able to just include it. I'm like, I didn't even put that in the assignment. Oh, how embarrassing that I didn't put what to include.
Libnet socket. libinetsocket.
Libinet socket.
Yeah.
No.
There's that, and then there's libunix socket.
No.
Those are the. I'm assuming it's not CONF because those are the only 3 H's, the H extensions. There's a bunch of other HPPs.
Yeah, libinetsocket.h. Oh, libinetsocket.h. That should have worked.
Does it need to be in quotes instead because it's on?
No, since we installed it.
With the MD5, we put it in quotes.
Right, because it was in our current directory.
Oh, I see.
But we've installed it off in the system directories. So.
Gotcha.
Oh, there we go. This is it.
Ah.
I will add this to my notes. Okay, so what we have to do is create a connection. Where's my picture here? Create a connection from our host over to this host here with this port number. And then we should be able to use just our standard fgetS to pull in a string, and then we can just print it on the screen. So we will go create.
We're still looking at your whiteboard.
Oh. Create inet stream socket, and then you pass in 4 pieces of information. The first one is the name of the host, the name of the computer you're connecting to. The second one is the port number, and then there's 2 other parameters that are just always the same. So it's going to be fremont.cs.sierra.college.edu is our host name. The port number, you still put it in quotes, even though it's a number. That's because you can pass in port names as well. You can pass in like HTTP, it'll connect to port 80 automatically.
Oh, that's cool.
Okay, the next parameter is in all caps, except for 1 letter, libsocket underscore IPv4, and the V is lowercase. And the 4th parameter is just 0. Now, this function will do the job of looking up the host name, translating it to an IP address, connecting to the port number, and then establishing the connection. Normally that would have taken 3 or 4 function calls if you're using the low-level socket library. This does it in just 1. And it returns to you a connection number called a file descriptor. So it doesn't return a file pointer like opening a file does. It just returns an integer to you, which is basically like your your socket number, if you will. So we'll create a variable called FD, file descriptor, that is the socket number that it created. Now, that's not very useful for us. What we want to do is actually have a file pointer so that we can use the functions that we're used to, like fscanf, fgetS, and so forth. So there is a function called fdopen that takes in a file descriptor number and turns it into a file pointer. So with fdopen, you pass in the file descriptor number, and you also pass in a string that says, how do you want to access this thing? Do you want to do a read-write, read only, and so forth? So we will go pass in fd, and we want to open this for R+. R+ means we want to read from this, and we also want to write to it. You don't put in RW, you put in R+.
Is that specific to just this, or is that just
No.
how you always do read and write?
That's how you do read and write. So if you wanted to
Okay.
open a regular file for read and write, you do R+.
Okay, cool.
It means you open on for reading plus writing.
Gotcha.
You can also do W+, which means open for writing plus reading. The problem with that is it will zero out the file first.
Oh, okay. So it's kind of like the append then, except it's reading it too.
Well, W+ means it's just like doing it right.
No. R+.
Oh, R+. Yeah, except it won't move you to the end. It still keeps you at the beginning, and you can start reading from there. Okay, so now that we have the socket open, we can then just do a fgetS. Then we can print it out on the screen. And then close our connection. And there's two things to close. We need to close the file pointer, and we need to close the file descriptors. There's two closes to do. We'll use an fclose on the socket, and then just simply close on the file descriptor.
Where is socket listed?
Oops, that should have been just sock.
Oh, that's what sock stands for, socket, okay.
Okay, let's save it, compile it, and it says close is invalid. So that's probably where we needed unistandard.h. Yeah. Okay, let's run it. There's our greeting. So every time we run this, it establishes a new connection over to the server, grabs that one line of text that it sent, and then prints it out on the screen. And we also get a blank line here below it because it includes a new line character. So that's it. Pretty small program.
Is it changing the greeting with the time or something? Like, why do you get different languages when you run at separate
Oh,
times?
it's just random.
Okay, cool.
And I think I only have 3 greetings in there. So next time, someone wanted to see the top of this. So here's the top. And then here's the actual program. So next time, I have another server set up. This one's running on port 2346. And this one, you can send it 3 commands. You can send it hello, 4 letters, all caps, and it will greet you in one of a variety of languages. You can send it the word date, and it will tell you the current date and time. And you can send it quit, and it will close the connection. That's it. But I'm leading you up to being able to have a 2-way conversation with a more sophisticated server for doing things like fetching files. I have one set up where you can request files to be downloaded. It will send them to you, and then your program needs to receive the file and save them to a disk, save them to a file on the local disk. Also, that's the way things like email programs work. When you send out an email, it makes a connection to an email server, and then it sends these commands like, I want to start an email, here's who it's going to, here's who it's coming from, here's the body of the message, and then send it. So it sends these sequence of commands over to the mail server. Works the same way.
Can I see the call to the create inet stream socket again?
Oh, we need to go all the way to...
It's giving me an undefined reference.
Check the capitalization on the libsocket IPv4. The V is lowercase.
Yep. LIBSOCKET underscore IP lowercase v4. That's right, 0. Yeah, it just says undefined reference to create inet stream socket.
Oh, then just make sure you got all this spelled correctly.
Create CREATEINETSTREAMSOCKET.
When you compile it, make sure you are linking to the socket library.
Ha! That's why.
Were you getting a
There we go.
compiler error or a loader error, a linker error?
Compiler. When I clang it.
Were you getting, were the errors prefixed with LD?
Yes, user bin LD.
So that's a linker error. So when it brings it all together, then it says, now I don't know what the name of your function is.
Gotcha. Buenos dias. Cool.
I should put in more languages. How about this? People who are on YouTube or people who are on Zoom, why don't you post a greeting that you would say in your language, since we've got people watching from all over the world. And then I can incorporate that into this program. Takes them about 20 seconds, right? Because they're on 20-second delay. Ben says, "How you doing?"
Oh yeah, we got bonjour. I don't know how to say that in Russian.
I'm incredibly wary of people who say howdy on the internet.
Oh, and John, I was going to tell you with taking the class that you want to take, the waitlist goes fast. So even though it's waitlisted all the way out.
Let's see, we've got ni hao, which is Chinese.
Yeah, I got some here.
What language is that?
Italian. Italian, and the lower one is German. You got konnichiwa already. That's funny. Portuguese is Ola, but it's spelled O-L-A with an accent.
I wish I could
Korean's
do the
cool.
foreign characters, and I can't because C just doesn't know Unicode.
Oh.
Not natively. So when we input, I should see what happens actually if we go and read the data in as characters and then print them out. It could be that even though it really only knows about ASCII characters, like, but if I just receive a Unicode character, will it work? And a Unicode character would be a sequence of characters. I don't know. I'm going to find out.
Danish is good too. What do they call that when it's the same front and back, like race car?
Palindrome.
Palindrome. Danish is a palindrome. French. French was the first one on here. Oh, bonjour. And then informal is salute with a T. Would be like that.
I'm putting them in. Oh, what'd you say Portuguese was? It was Ola.
Ola with an accented A. O-L-A.
All right, we'll try it. Let's see what happens. All right. So, interesting thing will be how many times we have to run it before it finally shows you that.
I just got Guten Tag. Bonjour. There it is. Hola. It worked. O-L-A. That's neat.
So what happens is when you send a Unicode character, it actually comes over as multiple characters. The sequence of multiple 8-bit characters. And it just knows that if the high bit is set on the first one, then it's a Unicode character. If the if the most significant bit is set on the first character, then it's a Unicode character. If the most significant bit on the first byte is not set, then it's an ASCII character. So it looks at the first character, it sees that it is, most significant bit is set, and so then it knows to receive some subsequent characters after that. Those then just get written into the character array. They're just 8-bit values. And then when they get sent to the terminal's doing the same thing. It sees that the first byte has the most significant bit set, so it knows that the next bytes coming out aren't part of that same Unicode character. So I can understand here why it would work, but you can't do things like, you can't have variable names that have Unicode characters in them.
Yeah. That makes sense.
You can't do things like string compares very easily with Unicode characters.
Yeah.
It just doesn't understand those. There are libraries for dealing with Unicode. You can't just subtract 32 from a foreign character and get its uppercase equivalent.
Yeah.
Someone here's got Greek. Oh, Jack's got Greek. Let me copy that.
Oh, geez. Did you just copy and paste that, or did you figure out how to write it, Jack?
Google Translate, right? Okay, so now my program greets in English, Japanese, Spanish, French. I don't know what this next one is. Boa tarde. And then Dobar dan, which is Serbian. And you have Italian here, German, Portuguese, French. Godag, is that like
That's Danish.
Danish?
Yep.
Sounds like an IKEA word, so.
It's funny because Danish, Godag, doesn't have a space, but in Swedish and Norwegian, it's Godag, but it's G-O-D space D-A-G.
Wait, IKEA
So
is
they just put a space there.
Norwegian?
Norwegian? Oh, Swedish is Norwegian?
No, is IKEA.
It's
Or is it
Swedish, yeah.
It's Swedish, okay.
Yeah.
Okay, so it sounds like a Lego word.
Yeah, it kind of does, doesn't it? Can you pass me one of those Godags? Thanks.
And then we have Greek in there. All right. So, like I said, next time we'll have this other program that you can have a very limited two-way conversation with. But again, it's an example of the client makes a connection to the server, and then it sends commands to the server, and the server fulfills those requests, and the client is able then send other requests. And who knows, maybe I'll expand it to be more than just hello, date, and quit. But,
Yeah, that's neat.
Right. All right. Well, I think that's about it. So again, for those of you in the United States, have a good Thanksgiving weekend, Thanksgiving holiday.
Yeah, you too.
We'll see you on Tuesday, and then we will.
You got it.
We will begin our final programming assignment, and also we need to start scheduling in our brief conferences with me. So you need to start wrapping up your programs over the next week and a half. Brief conferences with me in order to see what your portfolio of work is over the semester, and ultimately then what grade you get.
Cool. Sounds good.
All right.
Okay, well,
Okay.
yeah, we'll see you Tuesday.
Yep.
Have a good holiday.
You too.
Everything's given
Thanks.
you guys.
All right.
You too, man.
All right. Bye-bye.
Bye-bye.
All right, you YouTubing guys, gals. I hope you enjoyed today. I really liked setting up this demo with the oscilloscope. Doing that. I was up late last night getting it all set up. Among other things, I had to clear off my desk. My desk was just piled full of stuff. And so now you got a nice clean desk here. That was a lot of work on my part to get that all cleaned up. But I'm glad I got that going. It's one of those things where every semester I said, oh, I'm going to be doing networking. I ought to get this oscilloscope set up and working. And I never get around to doing that little demonstration. And so this time I said, I'm going to start 2 days early and I'm going to get that going. And I got it going. So I'm quite happy about that. All right, well, I'm going to call it. I'm going to call the end of the stream right now. And I hope you all have a great weekend. If you're in the United States, have a great Thanksgiving holiday. And we will see you on Tuesday. So we're going to be a whole week off before I see you again. Actually, if you're watching my other stream, my discrete structure stream, we'll have that on Wednesday, tomorrow. So if you're tuning into that, then I'll just be back tomorrow. But otherwise, I'll see you on Monday or Tuesday. Oh, am I going to be active on YouTube when the semester ends? I don't know. I would like to. Problem is, as a teacher, what happens is you end up putting off all sorts of things you ought to be doing so that you can focus on grading and getting assignments ready and preparing these lectures. And then come break time, that's when you do all that stuff. So I have like construction projects to do at home. And so we'll see. I would like to do some stuff. So I will, if I have some time to do it, certainly I'll post, when I schedule the stream in, then I think you all get a notification that something's coming up. So if that's going to happen, you'll get that notification and you'll know ahead of time that something's going to be happening within the next 24 hours. Alrighty. Well, again, thanks for joining me. It's good to see everyone from around the world on this, and I'll be back next week or tomorrow. All right. Well, have a great day, great evening, great morning, wherever you are. Take care. Bye-bye.